So this first part that it's giving you here is what we did before when we did exponentials. So on this, they gave us the points on the graph to the x. And it went all the way to 3 this time, but we had done this on the last section, and we just picked -2, -1, 0, 1, and 2, and plugged them into that equation. And that's where they got 1/4, 1/2, 1, and so on. And then, remember, we did transformation. So like this one, we moved x to the left 3, and we moved y up 2, but we changed the sign of y, and so on, and then we have a graph. So that's just old stuff. Do you remember when we find the inverse, like if you had the point 0, 1 here, how do you find the inverse of just that point? What's an inverse do with the x's and the y's? It flip-flops them, yeah. So numerically, what is done, you just switch the x and the y. All exponential functions had horizontal asymptotes. Like this one, it was at 2. It's a horizontal asymptote. If we did the inverse, what do you suppose is going to happen if you inverse a horizontal asymptote?
It becomes a vertical.
Yeah, that's exactly what's going to happen. So logarithms, when we graph them, are going to have vertical asymptotes. So it will become vertical.
Wait a minute, is all this graphing going to be on the test too?
Yes. Be looking for whatever I post tomorrow. We'll get through what we can get through today, but that way we can ask questions about it on Monday. Okay, so for the exponential function f of x above, we're going to make a table of the inverse functions. So this part should not be too hard at all. These points are given to us. How do we find the points on the inverse? Flip-flop it, yep. So it's 1 3/4, -5, 1 1/2, -4, and so on. If you get done writing those down, we're going to graph them on the grid right next to it. So if you want to start graphing them, that's cool. The inverse, good question. This is the inverse of the graph that's above it. Make it a different color. what kind of asymptote is this one going to have? Vertical. The horizontal asymptote was at y equals 2, right here. So the vertical asymptote is going to be at x equals 2. That's f inverse of x. Okay, so we're going to find the equation of the inverse of f of x. So we had a bunch of steps, but in a nutshell, just to review, it says analytically, that's with an equation, as opposed to on a graph. We just did it graphically. We're going to switch x and y in the equation. Makes sense, because that's how you find the inverse, is flip-flop x and y. And then we're going to solve the new equation for y. And then replace y with f inverse of x. And we've done inverses lots of times before. We're just now doing it for exponentials. It's going to be logs. Okay, so there's our f of x equation. That's the f of x after they made all the transformations to it. So I'm just going to rewrite it here. And instead of f of x, I'm going to put y. You can just scribble it out if you want to, or erase it. Or just do it on the next step, it's fine. So f of x we know is the same thing as y. And now our first step, according to my steps 1 and 2 up here, is what am I going to do? Yep, flip-flop x and y. So I've got x equals negative 2 y plus 3 to the y plus 3, plus 2. So now it's what we were doing before. We're solving for y. So we subtract 2 from both sides, this 2. We get x minus 2 is negative 2 to the y plus 3. What do I do to be able to get that exponent down? Sorry?
Do you log it?
Yeah, you log. You log both sides. Because if you have a log in front of it, then the exponent can come down in front. As long as you do it to both sides. So you have the log of x minus 2 equals the log of negative 2 to the y plus 3. So our whole point in doing that was to get this, and put it in front of the log. So log of x minus 2 equals y plus 3 times the log of negative 2. Is that a negative 2? Oh, yeah. Needed to get rid of that negative 2. I didn't notice it was a negative. Don't kill me. Don't erase all yours. I think you can just make some changes. I should have gotten rid of that negative before I tried to take the log. Why? Because I can't take the log of anything that's 0 or less. So I should have divided by negative